Mathematics Modeling Conference. I am Uthman Habib Olamilekan, popularly known as Bright. So today we are going to be discussing about the concept of numbers. What are numbers? Have you ever thought about what a number is? If yes, were you able to give a befitting definition to numbers? Without the use of any dictionary or any other devices, can you try to give me the definition of numbers in your mind? Okay, let's get started. A number is a word or symbol such as 5 or 16 that represent a specific amount or quantity. Number is generally a mathematics register. Hence, we say it is an arithmetic value which is used to represent the quality of an object. We use numbers in our day-to-day life activities such as counting money, calculating time, predicting things, and so on. We have different types of numbers in the number system. In this presentation, we are going to discuss the types of numbers in mathematics, the properties and their example. So, kindly stay focused. We have different types of numbers which are classified according to their properties, how they are represented on the number line, and how they behave practically. Each classification of numbers will be provided here with description, properties, and examples to understand in a better way. The first class of the types of numbers are taken from the primary levels. These are the even numbers, the odd numbers, the prime number, and the composite numbers. Then after this, we shall discuss about the fraction and the decimal numbers. Then I will give the definition of what is meant by natural numbers, the whole numbers, the integers, the rational numbers, the irrational numbers, and finally what a real number and what a complex number is. Now first to the even numbers. As it is said that it is very basic, even numbers are numbers that can be perfectly divided by 2 without any remainder. An even number can also be said as a number that is the multiple of 2's. For example, suppose Latif had 6 balls. If he tried to group them in pairs, he can pair all the 6 balls in 3 pairs, and there will be no ball left out separately or unpaired. Therefore, he can conclude that 6 is an even number. Examples of even number include 2, 4, 6, 8, 10, 12, and so on. Now to odd numbers. Odd number is the exact opposite of the even numbers. It cannot be divided by 2 without giving any remainder. For example, if the same boy named Latif decides to group 7 balls in pairs, at last is going to be left with 1 unpaired. That is why we call it odd numbers. So example of odd numbers include 1, 3, 5, 7, 9, and so on. Do you notice something? That I didn't put 0. Don't get confused. 0 is a neutral number. It is neither odd nor even. 0 is going to be explained later in this presentation, maybe when we are talking about integers. The next type of numbers we have are the prime and the composite numbers. Prime numbers are numbers that can only be divided by 1 and itself. Hence, it is not a product of any smaller number except by 1 and itself. For example, 5 is a prime number. The only way you can write 5 is 1 times 5, or you say 5 times 1. There is no other way you can write it except from that. While composite numbers are natural numbers which are greater than 1 and it's not prime. That is, all numbers that are not prime are actually composite numbers except from 1. The very last class of our discussion in this presentation is when we have the natural numbers, the whole numbers, the rational numbers, the irrational numbers, the complex, and the real number. Alright, heading to the natural numbers. Natural numbers are positive numbers which read from 1 to infinity. They are also called counting numbers because when we count things, do we count things from 0, 1, 2? No, we count things from 1, 2, 3, 4. Please ponder about this. If you want to count something, we don't really count something from 0, 1, 2 because we don't give 0 as a number to something. We start from 1. 1, 2, 3, 4. And also, we don't count numbers from negative. We don't give a negative position to something that appears concrete. Now to the whole numbers. Whole numbers are similar to natural numbers in properties, but this time you start from 0. 0, 1, 2, 3, 4, 5, and so on. So when you are starting the natural numbers with 0, we actually call them the whole numbers. And please remember, we also call numbers that are not divided whole numbers, a number that is standing on its own. For example, I have an orange that has not been divided into two. I can call it what? A whole orange. I can call it a whole orange. Next is the integer. These are all valued negative or positive numbers. All valued in the sense that they are not fraction and not decimal. The integers are generated from the set of counting number, that is natural numbers 1, 2, 3, and so on, with the operation of subtraction. When a counting number is subtracted from itself, the result is 0. For example, 4 minus 4 is 0. So 0 is an integer, but we call it a neutral integer because it carries no sign, either positive or negative. And that is why 0 is included in the integers. Also, when a larger number is subtracted from a lesser one, a negative number is gotten, and that is called a negative integer. In this way, every integer can be derived from the counting numbers, resulting in a set of numbers closed under the operation of subtraction, that is minus. Now to rational numbers. A rational number is any number that can be expressed in its quotient form, that is in the form P over Q, where P and Q are integers and Q is not equal to 0. The set of rational number is denoted by Q. In other words, if a number can be expressed as a fraction where both the numerator and the denominator are integers, the number is termed as a rational number. Irrational numbers are the direct opposite of the rationals, as their name implies. They are numbers that cannot be expressed in their quotient form. Examples of these numbers are pi, square root of 2, square root of 3, square root of 5, and so on. You cannot express them in their quotient form. That is, you cannot express them as fraction. And even if you try to express them as fraction, they would only give you a recurring fraction. The next and the very last class of number we have is the real and the complex number. The real number encompasses all the classes and the types of number we have discussed. The real numbers contain the rational and the irrational numbers. It is the general name for all common numbers. And lastly is the complex number. I hope you don't get frightened when you hear the word complex. Complex numbers are imaginary numbers. They are not real and it's not possible to have them in reality. A complex number is the sum of the real and the imaginary number. When a complex number is expressed in the standard form, it is written as A plus BI or A plus IB, depending on your method of writing. A is the real part, while BI is the imaginary part. For example, we have 5 plus 2i. 5 plus 2i is a complex number. So the real part of the complex number is 5 and the imaginary part of the complex number is 2. Thank you so much for listening and watching. We have come to the end of the session now and we can call it a session. Special thanks to our videography and cinematography tutor, Mr. Ogunrinu. May God continue to be with you and abide by you. Thank you very much, everyone.